So what if we change the volume? Well, sometimes changing the volume has an effect and sometimes it doesn't. Where we see the most effect is when we have a gas involved. We just studied gas laws. If we decrease the volume of a gas, that causes the pressure to increase, right? Increasing the pressure causes the gas molecules to be closer together, which is a lot like increasing the concentration. It's concentrating them by squeezing them together. It's like taking, let's see, what could we do? We could take, I don't know, football. You had two football teams out on the field, and you got 22 players out there, right? And they're spread out. They just ran a play, and now we're going to concentrate them, and we're going to push them all together into two huddles right on the 50-yard line. Now they're all much closer together, right? We've concentrated them. That's what happens when you decrease the volume of a gas, which causes the pressure to increase. The particles get a lot closer together. Now you can smell that guy, right? And you can hear what he's saying to you. When you were 50 yards apart, he was yelling and you didn't know what he was saying. There's more interaction. If we increase the volume, that will decrease the pressure. The molecules will spread apart, which is the same as lowering the concentration. So the idea here is the same. It's just a little about gases. So we can think of, oops, that's wrong. It says higher concentration. And this would be lower concentration. If we lower the number of moles of a gas by taking gas out, then the pressure at constant temperature and volume goes down, right? Because here we've got pressure and volume and temperature, and if we make N go down and we force temperature and volume to stay the same, then the pressure must go down, right? So what we'll find is that a system can relieve a pressure change by changing the moles of gas. So let's look at this. Here we've got a reaction in the gas state. Nitrogen and 3 hydrogen molecules are going to react to form 2 ammonia molecules, and it's at equilibrium. Now, if we decrease the volume, essentially increasing the pressure, we've got more molecules closer together. The pressure is greater. The equilibrium wants to fight back against the pressure. Here what's important is how many moles of gas particles are in the reactants. There's 3 moles of hydrogen and 1 mole of nitrogen. In the products, there's only 2 moles of gas. So if the reaction shifts to the left, we get more particles of gas. If it shifts to the right, we get fewer particles. Fewer particles, lowering N, would cause the pressure to go back down. So with gases, we have to think about it a little differently, but when we're increasing the pressure, that means we have to decrease the number of particles to fight back. I was going to write something, but, well, so if we increase pressure, it will shift so that it will lower the number of moles of gas. And how do you know which side is lower? Well, you look. This has 1 molecule and 3, so that's a total of 4, and on the right is 2. If we increase the volume, what does that do to the pressure? It decreases it, right? And so the equilibrium will shift in a way that wants to increase the pressure, to undo what was done to it, to fight back. So it will shift the opposite way and make more particles of gas. The pressure of a gas depends on the number of particles. It doesn't matter what they are. It's a weird thing about gases. So here's the summary. I'll let you read that. If the number of moles of gas particles on both sides is the same, changing the volume will have no effect on the reaction equilibrium. So let's look at this one. All of these are in the gas state. If we decrease the volume of the mixture, decreasing the volume, we're making it smaller, what does that do to the pressure? Pressure goes up. If the pressure goes up, the reaction will shift to counteract that. Does it want to make more molecules or fewer? It wants to make fewer. Because the pressure went up, it wants to make the pressure go down. How many particles on the left side? 3. There's 2 of these and 1 of those. On the right side, there's only 2 particles. So it will shift to the right. To offset or counteract the effect of decreasing the volume. I guess another way you could think of this, okay, this is a brand new analogy, so it's kind of rough. If you think about, maybe, I don't know, bumper boats. Maybe bumper boats would work. I don't know. This is where I'm going with this. Doubling up. Okay, so if you don't have enough bumper boats or enough cars for all the people, what happens? You put more in each vehicle instead of everybody taking their own, right? Here, when we go from the 3 molecules to the 2 molecules, what's happening is that one of these oxygen molecules is splitting up and doubling up with the SO2s, essentially riding in the same vehicle. So the total number of vehicles has been lowered because the atoms are I don't know if that helps at all. I'm going to stop with that one. I'll work on that next time I get to sleep. Okay, so what is the effect of increasing the volume? Increasing the volume decreases the pressure, which makes the reaction make more molecules. So that will go the opposite way. And that is how to think about questions like this. There's no math. Just think about, well, this change does what? And how can the reaction fight back? How can the equilibrium fight back and undo that? And the answer is shifting right, shifting left, or sometimes nothing happens.